Welcome back. Today I'm going to teach you how to solve quadratic equations using the quadratic formula. Now, once again, I'd like to remind you that there are actually three methods to solve quadratic equations. All right, the first way is factorization and then using the zero product rule, which you should have learned in Sec 2. Okay. Secondly, there's the completing the square method, which I just did in my previous video. And thirdly, there is the quadratic formula. Okay. Now, factorization and completing the square are more complex than quadratic formula. Okay, personally, I feel the quadratic formula is the easiest method because you're just substituting values into the formula and then getting the answer easily. Okay, for factorization, you have to think how to factorize. For completing the square, in fact, I would not recommend completing the square at all unless the question states that you have to complete the square. Okay, so how do I know when to use the quadratic formula? If the question is asking for answers in three significant figures or two decimal places, definitely you have to use the quadratic formula. You can't be using factorization. All right. So let's take a look at the quadratic formula. X equals to minus b plus minus square root b squared minus 4ac over 2a. Now, what are these a, b, and c referring to? Okay, they're referring to the quadratic equation where ax squared plus bx plus c equals to 0. For example, 3x squared plus 2x minus 5 equals to 0. Okay, in this case, a is always the coefficient of x squared, b is the coefficient of x, and c is the constant. So for my example here, a would be 3, b would be 2, and c would be minus 5 or negative 5. Okay, and that's how I'm going to use these three values to substitute it into this formula. Now, let's take a look at some examples. First example, solve the equation 3x squared minus 7x equals to 1, giving your answers correct in two decimal places. Now, it is always necessary to manipulate your equation such that it becomes the format of ax squared plus bx plus c equals to 0. Your right side needs to be 0. Okay, so when I look at this equation, I need to move this 1 over to the left. So it becomes this. So right now, you don't have to do this, but it's good practice. A equals to 3, b equals to minus 7, c equals to negative 1. So how do I present my working? X equals to, now you know the formula, negative b, so minus negative 7 plus minus square root b square. Now be careful, b square is this minus 4ac over 2a. Typical mistake for b square is students write this. Once they write this, it is wrong because you should know by now that negative 7 square in this format is not the same as negative 7 square because this is actually positive 49 because it's negative 7 times negative 7. However, if you key in a calculator, this is actually negative 49. So please do not make this mistake. Remember to put the brackets in when you're keying the calculator. So one more thing to remind you is that quadratic formula for this kind of equations, this kind of questions, it's 3 marks, okay? So you do need to show some working. You can't just key this in a calculator straight away and get the answer. So how would I do it? It would be 7 plus minus, and then I'll key in whatever's in the square root. 7 squared minus 4 times 3 times minus 1 equals to square root 61 over 6. So now I have two answers, plus minus. So I'll split it up. X equals to 7 plus square root 61 over 6, or 7 minus square root 61 over 6 equals to 2.47 in two decimal places, or minus 0.14. And there you go. I've effectively solved this equation using the quadratic formula. Okay, now let's move on to the next example. Example 2. Solve the equation 2x plus 1 times x minus 3 equals to 5. Giving your answers correct the 2 decimal places. Again, please look carefully at this equation and realize that it is not in the ax squared plus bx plus c equals to 0 format. Now, I also cannot say 2x plus 1 equals to 5 or x minus 3 equals to 5, right? Because that is not the zero product rule. So what do we do then? We have to do expansion. So let's write it out first. 2x plus 1, x minus 3 equals to 5. So expand 2x squared minus 6x plus x minus 3. Now this 5, I'll move it over to the left so that I get a 0 on the right. Simplify it. 2x squared negative 5x minus 8 equals to 0. Now I have my quadratic equation in the proper format, right? So now I can write out a equals to 2, b equals to negative 5, and c equals to negative 8. Okay, now I'm going to do my equation. X equals to negative b, so minus 5 plus minus square root b square bracket minus 4ac over 2a. So again, let's simplify this. Negative minus a negative 5 is positive. Plus minus, let's key that whatever's inside the square root. I get an 89 inside over 4. So x is actually equals to 5 plus square root 89 over 4, or x equals to 5 minus square root 89 over 4. And let's get our answers. 5 plus square root 89 over 4, 3.61. And if I put a minus 1.11. There we go. I've solved this equation again. So it's very standard, it's very simple. But you need to know how to expand and simplify this to get your quadratic equation. Okay, in the proper format, of course. So let's move on to example 3. Now you can see an algebraic fractional equation. Okay, this is definitely doesn't seem like a simple question. Now, even if for students who are not so experienced, okay, they would not be able to see that this is a quadratic equation. But doesn't matter. All you have to do is go and simplify it. You will end up with a quadratic equation. So let's start with this. 20 over x minus 20 over x plus 3 equals to 4. All right, I don't like to teach my students cross multiplying. I like to tell them that you have to change to the same denominator, and then you can cancel off the denominator. So what's the common denominator? X times x plus 3, right? So this is my common denominator. So what do I have to times here? X plus 3. X plus 3. I need to times that x here. And for this, I need to times both denominators. Now, based on the concept of if a over 3 equals to 5 over 3, you can cancel this and say a equals to 5, right? So now, right now I can cancel these denominators and I get an equation without any fractions. So what do I do now? I can simplify it. 20x plus 60 minus 20x, and I expand the right side, 4x squared plus 12x. Can you see 20x minus 20x? This is gone, right? It's 0. So I can actually say it's 4x squared plus 12x minus 60. If I move this over to the right, equals to 0. Now I think all can be divided by 3, or rather 4. So x squared plus 3x minus 15 equals to 0. Okay, so now again, I've simplified it into the proper quadratic equation format. So I can do the quadratic formula. Yeah? So a equals to 1, b equals to 3, c equals to negative 15. So let's do it up here. X equals to minus b plus minus square root b squared minus 4ac over 2a. Now you notice I didn't put my bracket here because it's positive. It doesn't matter whether I put a bracket or not. So simplify the square root. I get 69 over 2. So x equals to negative 3 plus square root 69 over 2, or x equals to minus 3 minus square root 69 over 2. And let's calculate our answers. 2.65 2 dp, or minus negative 5.65. So it's a very tedious process, but not difficult if you have a good foundation in algebraic manipulation from Sec 2. All right. So let's move on. Key points to note. If b is a negative number, example minus 3, remember that minus a negative 3 makes it a positive number. I think we saw this twice in my examples here. And if b is a negative number, bracket negative 3 bracket square makes it a positive number. So please remember to put your bracket for this b square if your b is a negative number. All right. I hope you learned something from today's lesson. If you learned something, please give my video a like. Thank you very much.